Aloha, Rich Halverson here. This is ITS128, and today I'm going to continue with go through the challenge exercises in Chapter 10 on exceptions. So let me share my screen. Okay, so before I do that, I'd like to remind you that if you click on Resources, and then you click on this side book section equivalencies, I am building a chart here of where all the videos are for all the labs. Okay, so if you're stuck on a lab, the labs, but you should really try to do the labs on your own. But when you're stuck and you're so stuck that you're willing to suffer through and have the patience to plug through a video to see how things are done, or see how I did them at one time, or did most of it. Sometimes I don't quite finish it, but there will be a video. And the chapter 9 videos are here. And so today I'm going to start with the challenge activities in chapter 10. In chapter 10, there are three. There's challenge activities in the first three sections. Okay, so exceptions. Now, we didn't have exceptions back when I started programming. Exceptions came about in like maybe the 1990s, when it became clear that the higher level language programmers needed to be able to handle hardware when unusual exceptions occurred. Exceptions that are so unusual that you're not going to really account for it in your regular code. But nonetheless, they can occur, and you want to account for them in some way. So, one may be dividing by zero. Your code you have an algorithm that's where the denominator should never be zero, so you don't bother checking each time before you do a division. But it's possible that, and it's usually a user input error that you didn't account for, that happens so rarely, and it's an error that you don't bother to account for in your code. There's also hardware exceptions, like the printer gets disconnected, or something like that kind of stuff. To handle exceptions, you have to say what code your exception handler, it's called an exception handler. You're going to write an exception handler to handle the particular exception. So you enclose the code that you want your exception handler to apply if the exception occurs, and that's called the try section of the code. And then there's the except section, where if the exception actually occurs. So here's an example of okay, so a user is going to read in here we ask the user to input a weight, and that's going to go in here, and we ask the user to input a height, and that's going to go in here, and then we're going to compute the BMI, and the BMI has got height in the denominator. So if somebody accidentally or on purpose enters in 0 for their height, then this code will explode, because this is gonna be turn into infinity, and then this is going to be infinity. So and so here we have where here for the weight, somebody enters in something like this, which is not even a number. It's not even a number. So it fails on this. It tries to, this int function tries to convert something that's not a number, which is this thing, this string of this string of characters here. It tries to convert that into a number, into an integer, and it can't. So this thing, so the program, you know, bombs, and we have this trace back, and on this statement, there was a value error, and it was an invalid literal for what should go inside the int function, or it's whatever was put inside this int function, namely this thing. Ended up not being, you know, a valid literal. In other words, it should be digits. So anyway, so what you can do is you can have this. Instead, you can, this is the code where you're reading everything and you're doing all the computations and everything. And so you put that in a try clause, or a try block. And then you have this except block, which will get executed if something bombs out when it's executing up here. And so, you know, a couple things can bomb out. You can enter in a bad height also, as I mentioned earlier. You can enter in a bad weight. So if that happens, then right then it stops doing whatever it's doing, jumps down to here, and prints that out, and then it's done. So then it can just go back, and so this is done. This try except is done. And so it's going to next it's going to do a user input, which is going to read it in again. It's going to come back around. So in this case, the bad input does not cause the program to bomb. The program handles it. It handles it with a try except block, a try block and an except block. That's how it ends. So that's what exceptions are all about. And from here on, we're going to distinguish between different types of exceptions. And we can put like an order to, you know, there can be something can cause multiple exceptions to occur. One event can cause multiple exceptions to occur, and you can put an order there, and all that. And that's what this is all about in this chapter. So here are some common, there's built-in exceptions, and then you can create your own kinds of exceptions if you want to, also like software exceptions. So here's some common built-in exceptions. There's an end of file error, and that's if you're reading a file and you have a while loop that's reading a file, and all of a sudden you hit the end of file. In other words, you try to read the file and there's nothing there to read. Well, that's an end of file error, and often that's the way that you can tell when you're done reading the file. So you can catch that exception by using a try catch, and then you can just continue on. A key error is when you're using a dictionary. This is the key of a dictionary, you know, the dictionary data type that we learned in lists and dictionaries. And to index an element in a dictionary, you use a key. Just like to index an element in a list, you use an integer index value. So anyway, that can be an error if you try to index an element in a dictionary with a particular key, and that there is no element in the dictionary that has that key. That would be a key error. And then here's a divide by zero error. And then here's some other kind of value error, like, and this is what you get if you are trying to read in an integer value, and then I don't have an answer for that. Is there something else I can? It's not good that Siri starts talking. So if you're asking the user for an integer and the user types in some letters, then that would cause a value error. If you are trying to reference or access an element in a list, and you try to use an index value that's bigger than the number of elements in the list, then that means, in other words, you're trying to reference an element that's not there, then that's an index error. So that's this kind. All right, let's do some challenges here. So type the programs out. Okay, great. So we're going to see if there's an error and everything, so on. Okay, so let's start this up. And so I'm going to first read in something from the user, and I'm going to try to convert that into an integer. And so this is the input, and oh, look, it's not an integer, so we're going to get an error. So it's going to jump down to the except, and it's going to print an X. Okay, X. And then it's going to go back. Oh, then it's done. It's done. Okay, there's no looping. All right, is this right? Yeah, it is. So it's not going to look at the 3 at all. Okay, let's do the next one. Okay, so we're going to read in an input, and there's no, this is not, we're not inside the try except yet. Anyway, if we read an input, if it's not equal to Q, then we're going to read another input, that's this one, and convert it into an integer, that's fine. So the number is going to equal 1. And then we're going to print 1 times 4, which is 1. No, it's 4. So it'll print out a 4. And then it looks like we're going to come down here, we're going to read in another input, and that's going to be the Q. And then it's going to come up here, and it's going to say, is user input not equal to Q? No, it is equal to Q. So we're going to skip out and print E, it looks like. E. Is this right? Uh-oh. Oh, wait a minute. Oh, I see what I did. Oh, okay. Yes, I thought that we were reading in another input. And so here I thought we were reading in a 1, but really we were using what we had input up here. So, and then we come back around and we input a 1. So this is way wrong. Okay, so let's do it again. Okay, we get a user input, and that's 8. And then is user input equal to Q? No, it's not. Is it not equal to Q? Yes, it's not equal to Q. So we're going to try this, and this is going to take a number, and number is going to now equal 8. And then it's going to take number times 2. Maybe I should pop up where's this thing? All right, let's see if this works. So do I have something to write with? Okay, so for this one, we start out with user input. User input equals 8, the character 8, like that. So I'm going to put a quotes with it. And then is user input equal to Q? No, it's not. So now I'm going to take number. I'm going to convert user input into an integer, and then I'm going to save that into number. So now number equals the value 8. And then I'm going to print number times 2. Number times 2 is 16. 8. So I'm going to print. I'm going to print 8 times 2 equals 16. So that's what I'm going to print. And so I'm going to print 16. And then I'm done. So I'm going to come back around and get another user input, come back up here as user int. So now user input's equal to 4. So now I'm going to go 4. And so it comes down here, converts it into a number 4, converts it into a number 4, and then 4 times 2 is 8. 4 times 2 is 8. And so 8 is what's printed. So I'm going to print an 8 here. And then I'm done with the try, and I'm going to do this user input here, and I'm going to get another one, and now it's 5, and now user input's equal to 5. And so, and 5 times turns into a 5. 5, that's a 5. And then this is going to be 10, because 5 times 2 is 10. So that's printed next. And then we come back around and we read 3, and that's going to be 3 times 2 is 6, so it's going to print a 6. And then it's going to read a Q, and it's not true that user input is not equal to Q. That's not true because it actually is equal to Q, so this is false. So we jump out of the while loop and we print an E. I hope this is right. Ah, yes, good deal, that's right. All right, let's try the number 3 here. This time we have, this one's this one. This one's times 4. Okay, so 9 times 4 is 36. 36, right? And then we have A, and A is going to be an exception. So it's going to print an X. And then we're going to do a 1. 1 times 4 is 4. And then we're going to do a Q, and it's going to quit, and it'll be an E. All right, one more. My goodness. Okay, so at this time, the while loop is inside the try. And so this means that we're going to do the while loop until either we get a user input of Q, because the user input is right inside the while loop. This while loop keeps on looping until it stops looping if we input a Q, or if we input something that causes an exception. In other words, and that might be something that could not convert it to an integer. And when the exception occurs, we jump out of here and we print the X, and then we're done with the try except statement, and then we can just print the E. So this is going to go until it gets an error, and then once it gets an error, it's just going to print the X, and it's going to print the E, and then we're done. If it's an error, or if it just gets a Q, then it's just going to print the E. So it's it's times 3. So the first one is going to be 3, and then 1 times 3 is 3, 4 times 3 is 12, 5 times 3 is 15, and then we get a Y. 6 times 3 is 18. Oops. So here's 18, 3, 12, 15, 18, and then we get this capital Y, and that cannot convert to an integer. So then we end up invoking the except clause. See right here, it causes an exception because we're trying to convert a capital Y to an integer, and it won't work. So then we execute the exception clause, and that's just going to print out a lowercase x. And then we're done with try except, and so we print the E. All right, let's see if this is right. Very good. Okay. All right, that's the first challenge. Let's move on. Multiple exception handlers. Okay, so we can have multiple exception handlers. So it just looks like this. And so when an exception occurs inside the normal code, it's just going to go down the line and go down and see until it matches the exception type. And so usually you're going to have at the very end, you're going to have a catch-all to catch all the other exceptions that could possibly occur that you didn't account for up here. So so here all right, let's just go through this and you can see this. So we'll do some error, do some stuff. Well, here it caused the type error, and so it's going to jump down and do the type error. It's going to skip the value error. It's going to come down and skip the type error, and then it's going to be done. So that's just basically how that works. So this has a try except a double one where this one will occur. A value error would occur if you input something that wasn't correct. You input something that couldn't be converted to an integer, for example. That would be a value error. But a divide by zero error would occur because here you have a division, and somehow this ended up being the value 0, and that would cause this zero division error. So anyway, so that's multiple exceptions. Let's do a challenge here. Okay, so here we have enter the output of multiple exception handlers. Okay, so it looks like we're going to look at a value error and we're going to do a zero division error. A zero division error could occur right here with this print statement. Value error could occur right here when you're wanting to input a divisor. So here, if you input a 0, that's a valid thing. Put a 0, it's going to divide, it's going to be 0. But then when you try to divide by 0, it's going to cause a zero division. So that's what this is. Let's just see what happens. Start here. Okay, so we're going to read something in. All right. So we've got user input. And that's going to be, first time it's going to be 0. Character 0. And is it equal to that? No, it's not. Are we able to convert 0 into an integer? Yes, we are. So that's fine. Divisor is now going to equal 0. And then we're going to try to calculate 60 divided by 0, and boom, that causes a zero division error. So we're going to print a z. So we're going to print a z. Z, enter. And then we're going to read another input. And what's the input? It's going to be 10. So now input is 10. 10. And that can convert into an integer fine. So the integer is going to be 10 that it converts to. And 60 divided by 10 is a perfectly fine number. That's going to be 6. So I'm going to print 6. Right? And then once I've printed 6, I'm going to come back down here. After all of the try except, I'm going to come down to the next statement. It's going to read again. It's going to read 5. And so input's going to be 5. And so divisor is going to be bung because it cannot convert 5 into an integer. That won't work. So we have a value error. It's going to print out a V. And then we come back and read in another user input. And this time it's 5, this 5. And so 5 is, this is going to end up being 5, just a regular 5. So the divisor is going to be 5. That's fine. And 60 divided by 5 is 15. No, 12. 15 divided by 60 divided by 5. 60 divided by 5 equals 12. Right? 12 times 7 is 50 is 60. So let's just put a 12 here. So that's what's printed. And then it comes back around and it reads in the end and reads in the end. And now this is false because it does in fact equal 8. And we come back here and we print OK. I think this is, does this look right? Yes. Okay, very good. Okay, let's do the next one. Okay, here we have we've got a list of numbers, 4 numbers, and we're going to read in some input, and then we're going to, while the input is not equal to AND, we're going to try some stuff, and if we can get a value error or a 0 division error, in which case it's going to do something. Or we can get a name error and a name error here. Is it because there's no because compute is not defined, right? Because there's no method named compute. So that's a naming error. I see. Very good. You'll learn something. This is going to cause an indexing error because we're going to try to I see. So we try to reference this. There's the only valid indexes for numbers would be 0, 1, 2, and 3. So if it's a negative number, then if this is a negative number, then that's going to cause an indexing error, which is going to come here. Okay, so that's all the errors. A value error is trying to convert, for example, converting something into an integer it's not a number. 0 division error is dividing by 0. A naming error is calling a method or calling a function that doesn't exist. That's an example of a naming error. A type of that's an example of a naming error. And then an indexing error, of course, is when you're trying to reference an element in a list that using an index that doesn't exist, or an element doesn't exist at the index, like negative indexes. All right, so let's run this. Oh, so let's do it. So the first thing it's going to try is -4. And you can divide by negative. Okay, so it's not going to hit this one. It's going to hit this one. So it's going to cause a negative number is going to, it's weird they call this divisor. It's to trying to trick you. All right, -4. When it comes down to here, divisor is what the -4 converted, -4, the string -4 converted into an integer is going to be the value -4, and so that's going to be divisor, and this is going to cause an index error. So it's going to be this exception. So it's going to print an S followed by space. And then we're going to come back around. It's going to read a 0, and we're going to get this error. And divide by 0, it's going to print an R, and then it's going to print an R space. And then we're going to read a regular 4, and that's going to be an index error because the index is too high. It's got to be 0, 1, 2, or 3. So that's going to be an index error. Again, no, it's going to be not this one, not this one. It's going to take 4 and divide 20 by 4, and you get 5. 20 divided by 4 is 5, and then we're going to print the 5 a lot after in a space, 5 space. And then next we're going to read in this FIVE, and that's going to cause this error because it's not going to be able to convert that into an integer, and so that's going to be a value error, and that's going to print an R space. And then we're going to read in -5, and that is going to cause another one of these. This error, index error, and so that's going to be an S. And then we're going to read an end, and so that comes up here, and it's going to print OK. All right, let's see what this is. It should have printed a 2. Okay, so the first one I got wrong. I had an S. Why did I have an S? Well, because -4, divisor is -4. Oh, I bet you, I know. I think you can have negative indexes in a list, can't you? I'm gonna test it. So to test it, I have to bring up the command line. And then I have to go, Python. And then I have to go this, copy. There we go. And then I have to go print, parentheses, numbers, -4. It does work. So -4. Why is it -4? Well, this is 0, -1, -2, -3, -4. Okay. So this does not cause an index error, and so it does not cause an index error. I should have known that you can have negative indexes. I just forgot. You can't have negative indexes in any other language. Pretty sure. And you have negative indexes in PHP. Oh, I guess you can. Oh. Well, anyway, so I'm getting sidetracked here. Well, that's interesting. You learn something new every day. In the old days, you couldn't do that for sure. All right, so let's try it again. We're going to get another chance here next. All right, 0. So 0 comes in, and I better do this. I'm going to do this again. Okay. So 0 comes in. User input is 0. User input equals 0. And that can convert to a divisor just fine. Divisor equals 0. This is actually a character string. Is divisor greater than 20? No, it's not. Is divisor less than 0? No, it's not. Otherwise, do 20 divided by divisor. Well, that's going to be a problem because divisor is 0. So this is going to cause a 0 division error. So we're going to print R followed by space. All right, what's next? For 10. 10. Divisor is going to be equal to 10. So is divisor greater than 20? No. Is divisor less than 0? No. Oh, here we are. 20 minus divided by 10 is 2. So we're going to print out a 2. And then we're going to go back out here and read another one. It's ONE. And we're going to get this error. Because this is not going to, divisors, it's ONE. ONE. And it's going to bomb right there with a value error. So R is going to be printed. R space. And then it comes back and it reads this -4. I've seen that before. So this is going to be -4. And this is going to be -4. And so is divisor greater than 20? No. Is divisor less than 0? Yes, it is. So numbers, -4 is what was it again? This is 0. -1, -2, -3, -4. So we're going to print out a 2. 2 is perfectly fine. And come back around and we're going to read the 100. And 100 is it's going to convert fine. 100 is going to convert fine. Do this. 100 is going to convert fine to 100. But then, is divisor greater than 20? Yes, it is. So it's going to try to do this compute thing, and it's going to get a name error. And name error is going to print out an S. And that's 100. And then it's going to do -10. All right. Now, so -10. -10. And so divisor is going to be -10. So is divisor less than 20? No, it's not. Is divisor less than 0? Yes, it is. So the question is, does numbers -10, does an index of -10 into numbers, does that work, or is that an error? Well, guess what? I got this here. Still have this up here. So I'm going to do print numbers -10. Bung. Index out of range. Well, what is the print numbers -5? That's about it, but that's out of range also. Yeah, it's -4 is not. Okay. So anyway, so it's out of range, and so we get an out of range, get a range error. Yeah. Index error. Index error. Haha, there it is. Index error. So that's what we get. So we're gonna do an S here, another S. Yeah, because this was a name error. Name error, and then a index error, and then it's gonna do end, and end will do okay. All right, let's see if this works. Hey, all right. Let's do the last one. Okay, so we've got the divisor is less than 0. We do the compute thing. Otherwise, we divide by 0. And there can be a value error, there can be a zero division error, and there can be any other kind of error. We'll read it again. Oh, it's just once inside the while loop. That's okay. It's okay. So it's going to keep on looping until it gets to end again. All right. Let's start this up again. I'm going to erase this. And user input is going to be user input is equal to, I'm going to put this up here. I'll do that. Okay, first of all, user input can equal 0. And so is it equal to that? No, convert it into an integer. That works. So a divisor is equals 0, the number 0. And we come down here, is divisor less than 0? No, it's not. Otherwise, try to print out 20 divided by 0. That's going to cause an error. So it has a zero division error, so it's going to print out a z followed by a space. A z followed by a space. Then it's going to come back around. It's going to read in 2. So now it's equal to 2. And so divisor is equal to 2. And is divisor less than 0? No. So it does this. What's 20 divided by 2 is 10. So it's going to print the 10, followed by a space. 10 space. And then it's going to come out to here and read in another input. And now it's going to be the word 5. 5. And then it's not going to be able to, it's going to cause a value error because it can't convert FIVE into an integer. So the value error is here. And so then it's going to print a V followed by a space. And then we do -7. Comes back around, do -7. -7. So a divisor is equal to 7. So it's, divisor is equal to -7. So is divisor less than 0? Yes, it is. So then we get this naming error because there is no compute function. So we get except we could go down here to this error because it's not listed up here or here. It's a naming error. So let's print an X followed by a space. X space. And then we're going to come back around and we get the word end. And it is equal to end. Then, well, this is false now, so it's going to come out here and print okay. Okay. All right, check. Very good. Okay. All right, so you should be able to do yours. Raising exceptions. That's the last one in here. Exceptions with functions. Finally, using a finally to clean up, and then custom exception types. All right, so here, consider the BMI example in which the user enters a weight and a height and outputs the corresponding body mass index. The programmer may wish to ensure that the user enters only valid heights and weights, and thus the programmer must introduce error checking code. The naive approach to adding error checking code is to intersperse if-then statements throughout the normal code. By the way, before we could actually have exception handlers back in the 80s, we had to write code like this. This is what we had to do. Anyway, so I wouldn't call it the naive approach. I would call it the before exceptions approach or something. So anyway, so what we can do is we can have our own we can we can cause an exception to occur manually using the raise statement. So we can raise the value error exception. And then we can even put in what the error is going to be. So so here, normally if you would enter in a weight that's not an integer, you'd get a value error. But now, even if you enter in a weight that's an integer, but it's a negative number, then we're also going to call that a value error. We're going to also call that a value error, and it's going to be this kind of error. So here's this and this. And then here we enter in an A, and an A. I enter in the weight, and the height is minus, and so we get an invalid height, or invalid height error value there. Anyway, okay, so that's raising exceptions, and so let's do this challenge activity here. So in this example, before we start, we read in a user's age, 30. If it's less than 0, then it's going to be raise this value error, and then this is the exception. I guess it actually prints out that. Let's see. So 30, average this. All right. So I'm going to start this. And all right, let's see what happens. I input an 80, so this is going to be 80, an integer 80. If it's less than 0, that's fine. Otherwise, I'm going to take 220 minus 80, and so 220 minus 80 is going to equal 140, right? 140. So average heart rate is 140. And so it's going to print out AVG colon space 140. I think. Enter. All right. Is that right? Yeah, that's great. Great. What's next? Minus. So this is going to print out user age is going to be minus 80. If the user age is less than 0, it's going to raise a value error. So it's going to print out this thing. I guess it's going to print out error, colon, space, and then whatever the exception clause is. So I would say it's invalid age. Enter. Well, wait. What's next? So first it's going to read in that, first it's going to say that this is false. Then while it's false, we're going to try to read in a password, and that's going to be this. So password is equal to this. Let's do this. So password is equal to potato 50, 150. Okay, and that's that. Is the length of password less than 8? No, it's not true. So it is a valid password. So then it prints out accepted. Okay. All right, is that it? All right. All right. Valid password is false. Well, it's false. Try, agree to a new one. If it's less than 8, valid. Otherwise, so it's a true. Okay, so the first one. Okay, so anyway, the first, it reads an input. It's pink 147. That's 1, 2, 3, 4, 5, 6, 7. I see it's only 7. Okay. So since pink 147 is only 7, then it's going to get this error. And it's going to raise the error. And so it's going to print out. Interesting. Okay, interesting. Okay, it's going to print out, it's going to print out error, colon, invalid password. No, it's just invalid. Enter. And then it's going to come back up to the top, and valid password is still going to be false, because the only time valid password changes to true is when this is executed. And this wasn't executed because we raised an exception right here. So this never gets executed. And so we're down here again, come back around, we read in a new password, and that's this thing. And this thing is 1, 2, 3, 4, 5, 6, 7, 8, 9. This has 9, a length of 9. So this does not happen. So it's a valid password is true. And so we're going to print out accepted. Accepted. All right, is this correct? Well, that's great. Okay, let's go through the rest of these, even though there's no challenge activities. We can have functions where exceptions with functions. And so so here, for example, this is the code. This is the code we're executing. And these are functions. Okay, these are functions that are called by this code. You see, get weight is called here, and get height is called here. That's get weight, get height. And you notice these two methods methods and functions is synonymous. Here we read in, we ask the user to enter a weight, and here we ask the user to enter a height. And we do this error checking inside. Inside these functions, these methods, and the exception handler is outside. So an exception may occur inside here, exception may occur inside here, and if it does, if one of these exceptions occurs, then it's gonna notice that there's no exception handler inside. Let's say they enter invalid height. We raise a value error exception here, but there is no exception handler here. So it automatically returns out, and it returns back out to here, and then it sees if there's an exception handler at this level, because it's inside the try. That's right. I forgot about that. It's a very important point. Because this is executed inside this try, then a value error, an error that's raised inside the try, and this is certainly inside the try, then this bumps you out of the try, and it executes the accept block right here. So you can have functions inside, and you can also have this At the end, you can have a finally to clean up. And so the finally is always executed. So, if no exception occurs, the execution continues in the finally clause and it proceeds to the rest of the program. If a handled exception occurs, an exception handler executes, and then the finally clause also executes. So anyway, that's the finally clause. I don't know. I can't think of how you'd ever use it, why you wouldn't just continue on without it. But anyway, it's a way to keep your code more organized. And then you can also have custom exception types where you can kind of make up your own thing. And here you define a class, you define classes of exceptions. And so they are just, you know, of type, they're custom exceptions, custom classes built off the exception type, the exception class. So so once you define, for this, for example, this one, once you define an exception class called, for example, less than 0, you call it a less than 0 error. Then down here, you can raise it, and it whatever happens when it's raised is defined inside the class here. So anyway, there's no and so the next ones are labs 7, 8, and 9, and it looks like 7, 8, and 9 are available if you look in the in these. If you look in these playlists, and these are what the labs were numbered. These were the numbers of the labs in these older playlists. Okay, so it's 10.7 in this Zybook's textbook is the same as 10.8 in the previous one. So when you're searching through the video, it's going to be in video number 3. So when you look in video number 3, you look until you find, if you look until you find me doing lab 10.8, and that's actually 10.7 for today. So anyway, so I pretty much, I think, finished covering chapter 10 for you. And so in my next video, I'll dive into chapter 11. Hope this helps. Thanks for watching.